With the global pandemic disrupting the worldwide supply chain in almost all industries, it is only a matter of fact how adaptive a particular industry is to the changes. The case focuses on three challenges that have to be faced by MediCrystal, a leading supplier in the pharmaceutical industry for this global pandemic. Here's our solution to this case. The current challenge of MediCrystal are to look for suppliers with least potential risk, estimate the change in inventory, and assess the potential capacity constraint. Our goal is to present a sustainable supply chain plan for MediCrystal, meet the forecasted demand of the vaccine accessories, and ensure the uninterrupted production of other critical vaccine amidst this. The first task is identifying which supplier of MediCrystal possesses the most risks based on the domains available for supply data. The task was approached in an analytical hierarchy process where the alternatives are weighted. Under multiple attributes, they were developing a numerical score to rank each decision based on how well each alternative meets them. Here in the supply data, we classify the risk factors in broadly three domains: financial, delivery, and regulatory. We considered these three domains as alternatives to each other for our ultimate decision. The approach was considered for the given advantages. For this, we developed a priority matrix on these three domains. Then we developed a standardized and CI matrix out of our prioritized matrix and calculated the eigenvalue of the consistency matrix. Then the CI was calculated, and following it, the CR was also calculated. We figured out that the financial domain has 22.38% weight of the entire risk assessment. The delivery domain has 58.58%, which is the maximum, and the regulatory domain consists 19.03%. We developed a standard scale of 0 to 100 for each of the subcategories, which is shown in the legend. Here 0 means least or no risk potential, and 100 means the maximum risk potential. The given data for each of the subcategories of the risk domain for every supplier was compared with the standardized scale. The sum of the standardized scale data of the subcategories was multiplied by the weight percentage of the respective risk domain. The cumulative score of the weighted risk score for individual supplier was calculated, then they were sorted based on the highest to lowest. The visual interpretation of the data shows that Bestoglass from the United States has the highest risk based on the given data in these domains, followed by Pharmalifa from India, and so on.
Moving on to task 2, the exhibit requires us to estimate the changes in inventory position as well as the obsolete inventory that Glassworks currently have. Based on the data provided, we have carried out simple mathematical calculations and analyzed the current conditions with respect to the factors provided. Our first step was calculating the on-hand stock units by dividing the total on-hand stock by the respective standard price. We converted the APU trend into a more easy-to-read format, eliminating negative values, and named the column APU trend V1. The exhibit stated 3 different variations per month, and in order to make the calculations easier, we multiplied each factor, the APU trend, demand variability, and SOTD, and found the variation factor for each SKU. Afterwards, using the product of the APU and the variation factor, we calculated the monthly average sales, keeping the variation factor into consideration. In order to find whether each SKU was in shortage or surplus, we deducted the monthly average sales with variation factor from the on-hand stock unit. The values inside the parentheses denote shortage. Our initial task in Exhibit 2 was to find the inventory position, and in order to find that, we multiplied the shortage or surplus with its standard price. Therefore, we obtained the current inventory in dollars. Secondly, we were assigned to find the obsolete inventory, and it was only a matter of filtering out of the products. Since the expiry date ranged to a maximum of 1 year or 12 months, we filtered out the SKU with a monthly coverage over 12 months, thereby sorting out the obsolete inventory amongst the 2,000 units. 39 SKUs were determined as obsolete. The sorted obsolete inventory is shown in the following slide.
The third task focuses on the capacity constraints for fabricatas alongside determining whose statement is justified, the plant manager or VP operations. We analyzed the given data, and here's our findings. On an average, we saw that the mean cycle time for the products is roughly 60 hours. However, looking into the 4-step manufacturing process of all 3 products, we came into an understanding that the cycle time is only for the primary cycle. Since it's a continuous process, we determined that the following lots will require a cumulative time equivalent to their washing time, and it is 19 hours for ampoules, 22 hours for vials, and 20 hours for syringes respectively. This is due to the allowing the next batch to start its production before the end of the previous batch. Based on the Exhibit 4, we can see that an average of 145 days the factory remains closed, and if we assume that the factory operates 24 hours a day, for the remaining 220 days, we will have 55 days of water for full-fledged operation. We have a total of 1320 hours, and if we calculate the numbers of the batches of the product produced, we gain a final of 71 lots of ampoules, 60 lots of vials, and 71 lots of syringes, from which rejected products are required to be eliminated. The final lot number stands 58 lots of ampoules, 45 lots of vials, and 57 lots of syringes. From the following values, we can deduce that the demand requirement will not meet 100% even if the factory operates 24 hours a day. In addition, it is not a practical approach to keep the factory running 24/7, and if a new cycle starts, an average of 60 hours will be required for the first cycle all over again. The VP operations might have not considered the unplanned shutdowns, or maybe didn't have sufficient idea on the capacity constraints, which are the tubing and forming sections. Considering the master production scheduling, we suggest an installation of an additional tubing and forming counter, which hinders the process. Thank you very much. That's all from us.